Hi, my name is Scott.
Hi, I'm Arslan.
Hey, I'm Erica. Hi, I'm Marina.
This is DARE, Disability and Rehabilitation Engineering. We are focused on universal design that allows anybody to have affordability, adaptability, and attainability for products that they need. This product was built around a gentleman with 3 disarticulations. Here is his brace and an arm that self-locks as necessary. We have the mobility wrist, which opens and locks as necessary for the different kind of activities or days or any kind of event that he needs them. So there will be about a dozen or so items that will be fastened to this. So for, like, say, one will have a utensil holder, so like something that will hold a fork. One that will lock onto, say, maybe a fishing rod, or something that will hold a vacuum cleaner, anything that he needs for like day-to-day activities. So he'll have a slew of those. This locks into place. And the important thing is to know that this is scalable. It's cheap and scalable, but also maintains the integrity and is able to be provided to those who need it in a more timely manner. This brace here will go across his chest because there's this articulation here. So for anybody who has like a below the elbow or below the shoulder amputation, there's usually a sock form that goes in here and attaches that way. But for him with the disarticulation, you need the whole brace, and it'll be strapped around both his wrist and across his shoulder. So his request was that there was nothing electronic, so everything here is mechanical. It's 3D printed and fastened with bolts and nuts.
Something that I shared with last year. So being assistive technology, I know that I've developed in this program, I've developed a reputation of not liking, or maybe I should say favoring, what we call low-tech assistive technology versus high-tech assistive technology. And low-tech meaning, how many of you have ever seen a reacher? We call them reachers, some people call them grabbers. That's my favorite piece of assistive technology right there. Because I can tell you that with my power chair at 300 pounds and me at another 100, I can run that baby over and it never breaks. I love low-tech technology, and because I can count on it.
The whole goal here is to help people who don't have the facility or the financial opportunities or the access for some prosthetic that might be $15,000 to $20,000. For the same type of like functionality, something like this costs 15, 20, 10, 15, 20, depending on the type, like my electric, 25, 50 to 100,000. This is like 100 of the cost. So affordability with that design in the public domain, somebody can print this on their own for a family member or somebody in the field who actually and not have to worry about something or some kind of complication. This is all going to be available to anybody that needs it. So that was the goal behind this, was making sure that people who need something can access it. So affordability, feasibility, capability, and functionality.
The design process here is factored around the patients or the clients that we have to build them for. So we have to consider what their day in a life is.
Hi everybody, my name is Arslan. I had the opportunity to work on the robotic arm that we designed as part of universal design being the phenomena that we're trying to achieve here in our project. So for the robotic door opener, we have 1, 2 points of rotation. These points of rotation allow for this mechanism to approach a door latch and open it up, and allows that individual to go through the doors and public access ways. When we talked about affordability and modularity, this entire assembly, as far as the fixturing, is 3D printed. We have some high-speed linear actuators and high-geared motors that allow for a lot of torque that allow to open the doors and open doorknobs and door handles. throughout our design process, we learned a lot of things. One thing for specific, we found out that there's a carbon fiber infused 3D printing material that would allow for higher strength. So none of these, sub-assemblies crack under pressure or they don't break under pressure. A lot of these dynamic rotating parts will also be fatigue free. So they're not going to, with multiple cycles, they're not going to be damaged or be at the point of replacement. From the side of the assembly over here, this aluminum bar with the latch clips allows this to be mounted onto any wheelchair that's available in the market.
Important thing, the most important aspect of your work is who you're building it for. It's not about what I think you need. I can give you suggestions. I mean, ultimately, you all are the ones that know the resources that are available, right? That's what makes you so valuable. And that's what makes us valuable, is we know about the resources. And so we try to line them up with the needs stated by the people.